Welcome in the inorganic chemistry practical. We are performing the next experiment of the inorganic chemistry, okay, that is determine the percentage purity of given inorganic salts and the qualitative analysis for cations and anions by wet test only. Okay, so this experiment has two parts. Okay, so both parts we have to do in a single practical, qualitative analysis as well as quantitative analysis. So according to our syllabus, the first part is quantitative analysis. Okay, so for this experiment we are performing the first part of that experiment, that is quantitative analysis. And for the quantitative analysis, so required the requirements. Okay, so this requirement includes the titrometric analysis instrumentations. That is, you know that very well. That is your burette. Okay, so this is your 10 ml pipette. Then required conical flasks. Okay, so these are the beakers whenever we have to pour the solutions into the burette. Okay, and somewhere when we need that is a glass rod, we need a dropper. Okay, and along with that we have is a standard measuring flask. Okay, so that we have to prepare solutions of our copper sulfate. Okay, next chemicals we require, that is first one is inorganic salts, that is given to us. We have to determine whether it is a pure or impure by this method. And second one we require, this is the 10% Ki solutions. This is a 2 molar acetic acid solutions. Then this is your 0.02 normal sodium thiosulphate solutions. And the last one, that is your starch indicator. All these are the requirements for performing this quantitative analysis of this experiment. Okay, so let's start. We have supplied this copper sulfate. First of all, we have to dissolve this mixture into a minimum amount of water. Okay, so for that purpose I transfer this mixture into the beaker very safely. Okay, and as it not need to have any content to this filter paper, that's why I am adding this distilled water on this filter paper, due to which I can collect all the parts of the complex very easily. Okay, so what I done here, very simply transferred all the, see here, transferred all the content of copper that is supplied inorganic salts into the beaker. First we have to dissolve it in a minimum quantity of water with the help of this glass rod. Okay, so I am going to dissolve confirm all the crystals of the salts get dissolved. Okay, so this is I think it's now clear solutions, is it right? Okay, so this is your clear solutions transferred into the standard measuring flask. Okay, so pour all these content of copper sulfate or the supplied inorganic salts. Now for maintain the lower meniscus, as it is a clear solution, so we have to consider the lower meniscus. Okay, so I will take the help of this glass rod to pour the solutions along the sides. Okay, so slowly traces, so you can see clearly how it maintain a lower meniscus. Okay, so in this way you have to prepare. This is your 100 ml, okay, supplied solutions. Okay, so this is a diluted solutions of the salt. Okay, salt is given to you, and that salt is converted into a solutions. Okay, now we have to determine its percentage of purity, whether it is a pure or impure. So what much amount of salt is given to you? That is a 0.5 gram. Titrate it 10 ml of these solutions with the help of sodium thiosulphate solutions. For that I want to fill up our burette first. Okay, with titrant that we called sodium thiosulphate. So I first rinse this burette. Okay, so take a few ml of sodium thiosulphate solutions, then rinse this burette with this sodium thiosulphate solutions likewise. After rinsing this burette, you have to remove this content. Okay, so due to which now in this way we rinse whole burette. Now I am taking this sodium thiosulphate solutions, so I just fill this burette with sodium thiosulphate solution. So I just fill. Why it is more than 0? Because we have to remove the air gap which is present in this nozzle region. Okay, so you are observing here the air gap. Okay, so that air gap we have to remove. So how to remove? So gently open this knob. Okay, due to which the solutions will move faster likewise. Okay, so see here now all the air now removed from this burette, due to which we can measure the readings accurately. Okay, now after removing this air gap, we have to adjust this burette at a 0 and see its lower meniscus very clearly. Okay, so slowly okay, so clearly you are observing here the lower meniscus, this lower meniscus of sodium thiosulphate, that is reached it at 0. Why we are discussing with the lower meniscus? Because it is a colorless solutions. Okay, so this is adjust burette. Now we have to titrate our supplied copper sulfate solutions. Okay, so I use this one beaker. Again I am transfer first it into the beaker. From that beaker I will going to pipette out a 10 ml of the solutions. Okay, so for that purpose I am using here a bubbler. First take more solutions than the marking. Okay, so you can see here the 0. So slowly decrease the pressure of your thumb. Okay, likewise. So in this way slowly we have to maintain this lower meniscus again, and it is pipetted 10 ml of solutions, transferred it into the conical flask. So it is transferred, hold the content, 10 ml of content of test solutions into the conical flask. Then we have to convert. Okay, so what it may be, the copper ions are there, that copper ions which are present in a solutions, that we have to make a free. Okay, so as it is present in a copper sulfate. So first of all we have to convert that copper ions into a copper hydroxides by making these solutions alkaline. For making these alkaline solutions, we are going to use a base that is a sodium carbonate. Okay, so this sodium carbonate will precipitate the we have to just use a pinch, okay, for precipitating this copper ions into the copper hydroxide. Okay, so this, with the help of alkaline, this sodium carbonate convert these copper ions into a copper hydroxides, right? You are observing now it's forming a precipitate, right? You are observing. So I just slightly add more, one pinch, okay, and now all the ions of the copper found to be a convert into the copper hydroxide, right? See carefully, this solutions becomes a turbid. Okay, now dissolve that precipitate by using acidic solution. So this solution is your acidic. Okay, we know that now basic solutions, how it becomes clear, by using the acid. For that we are using this 2 normal acetic acid. So this acetic acid we are using for dissolving this precipitate. We have to take a few drops for dissolving it and make it clear solutions. Okay, take it, observe carefully by adding a drops of acetic acid solution, shake it, okay, up to what we are adding a drops of acetic acid to becomes regain a clear solutions. Okay, and then we have to add 1 to 2 drops in excess. Okay, so I just adding 1 drop in excess. Now once again, dear students, you are observing here, this is a clear solutions. Now you are thinking that why we convert first into a precipitate and then again we are converting it into a clear solutions. Okay, so the reason behind it, that is what it may be, the copper which is in salt form, that is a copper sulfate pentahydrate. First of all we have to make them free from that copper sulfate by adding a base, that is a sodium carbonate, and it convert into the copper hydroxide. Now this copper hydroxide, that is alkaline solutions, once again we neutralize it with the help of acetic acids. Now these copper ions are free, dear students. Now after free these copper ions, we have to add near about 1 test tube of Ki solutions. This is a Ki, okay, potassium iodide solutions, that is a 10%. Okay, so just we are taking it near about 1 test tube. One test tube. Okay, so pour it into our solutions. Now our solutions becomes a yellow in color, right? So this yellow color we have to titrate against our sodium thiosulphate solution to make this faint solutions, due to which starch will shows you the clear color changes. Okay, that's why we are adding a few ml of sodium thiosulphate solutions. Before add indicator, okay, now it is a faint. Now I am going to add a starch indicator. Okay, so this is your starch indicator. Now just pour the drops of starch indicator into the flask. Adding this starch indicator, the solutions becomes a blue. Okay, now we have to titrate until this solutions is colorless. Okay, so the whole color get disappear now, right? So stop the additions of our sodium thiosulphate and observe the readings. If you see carefully, so the lower meniscus, if we consider, then the reading is near about 9.7. So this, note down, this is the first reading of your titrations. Likewise, we have to take 3 more readings. I am washing this. Okay. Then we have to again pour it at 0, adjust the burette at 0. Okay, so exactly that is lower meniscus reach at 0. Same thing we have to pipette out 10 ml of solutions. It must run slow. Okay, so this is the 10 ml. Pour it into the conical flask. Okay. Then we have to add a pinch of sodium carbonate. It gives you the precipitate, right? And that obtained precipitate we have to dissolve with the help of 2 normal acetic acid solutions by adding a drop wise. Okay, and after making it clear, add excess 1 to 2 drops. 1, 2. We have to add 1 test tube of Ki solutions. Once again, I am taking 1 test tube of Ki solutions. Solutions becomes a dark yellow color. Now use some sodium thiosulphate to make it faint. We are just add a few ml of sodium thiosulphate to make it faint. After making the faint color, okay, see carefully, we have to just add a starch indicator. After adding this starch indicator, our solutions must turns in dark blue color. Okay, so you are observing this is a blue color. Okay, and then add sodium thiosulphate drop wise, continue the titrations. These titrations is continued till that blue color changes into the colorless. Start the solutions and observe the colors. Okay, so once again it just turns in white in color. Okay, converted. Okay, so see carefully, it converted into the clear white color solutions. Okay, so you must be these clear solutions or either white precipitate. Okay, so you are observing, we are observing here the white precipitate. Okay, and once again you are observing the readings. Okay, so this times it is a 9.8. so last time that is 9.7 and this time 9.8. so these are the two readings. One more readings we have to take, that is a third reading. Okay, so see, third times when we are performing the experiment same, you are observing this reading also. So see carefully, the reading is near about once again 9.7. So these three readings we are taken, and out of which we got a two constant reading, that is a 9.7. Okay, so note down, that is your constant burette reading is 9.7. Okay, so after getting that 9.7, so the calculatory part we will going to discuss with the help of presentations.
Now, dear students, let's we discuss the calculations. For the calculations parts, let's focus on the observations. So the first one, observations, that is supplied weight of mixtures was given 0.5 gram. The titrant was 0.02 normal sodium thiosulphate, that is Na2S2O3. Titrant 10 ml of diluted solutions of mixture. Indicator was starch, and the endpoint was blue to colorless or white precipitate. Observation table. So in the observation table you can see the serial number, that is 1, 2 and 3, burette reading in cm cube, where initial burette reading, final burette reading, difference burette reading and the constant, all these are in centimeter cube. So the first reading having initial 0 earlier, then finally is 9.7, that the difference is 9.7. Similarly, when we take the second reading, initially which was 0.0, then finally we obtain 9.8. When we calculate the difference, then it is 9.8. Finally, when we take a third reading, initially it was 0.0, finally it obtained 9.7, then the difference was 9.7. Hence we obtain these three readings for 3 times titrations, so out of which 9.7 is a constant, and hence which is taken in a constant burette reading, that is 9.7. Now the reactions, what happens when in between the solutions. So earlier we taken the copper sulfate in aqueous solutions, we added where the Ki. So after additions of the Ki, which converts that copper ions into the copper iodide, cupric iodide, and forms K2SO4, and I2 is liberated. So liberated I2 and combinations with the copper I2 is same. So amount of iodine react with the copper, which is equal to liberated iodine, and hence when we calculate this liberated iodine, then we will get the amount of copper also. Hence this titration is also called as iodometric titration. So this liberated iodine react with sodium thiosulphate, which is added from the burette. It gives sodium disulfide plus 2 times sodium iodide. Then calculations. So 10 ml of diluted solutions required, 9.7 ml of 0.02 normal sodium thiosulfate. Hence 100 cm cube of diluted solutions required, 9.7 into 10 is equal to 97 centimeter cube of 0.02 normal sodium thiosulfate solution. 1000 cm cube of 1 normal sodium thiosulfide, which is equal to 63.54 gram of copper ions, and 249.54 gram of copper sulfate pentahydrate. Therefore 97 centimeter cube of 0.02 normal sodium thiosulfide, which is equal to 63.54 into 97 into 0.02 divided by 1000 into 1, which is equal to 0.123 gram of copper ion. Similarly, when we estimate the amount of copper sulfate, then it is 249.54 into 97 into 0.02 divided by 1000 into 1, which is equal to 0.48 gram of copper sulfate pentahydrate. Continued part of the calculations. Supplied mixtures of copper sulfate pentahydrate plus impurity was 0.5 gram. Then obtained weight by calculations of copper sulfate pentahydrate is 0.48 gram. Therefore, the amount of impurity is present in a supplied salt is 0.5 minus 0.48, which is equal to 0.02 gram. Therefore, the percentage purity of supplied mixture is equal to obtained weight of copper sulfate pentahydrate divided by supplied weight of copper sulfate pentahydrate into 100, which is equal to 0.48 divided by 0.50 into 100, which is equal to 96%. From this we can calculate the result. So the first, in that results, you have to write this result in this format. So the first one, supplied weight of mixture is 0.5 gram. Then obtained weight of copper sulfate pentahydrate after titrations, titrometric estimation, 0.48 gram. Therefore, third one, that is percentage purity of the mixture, is 96%.